Welcome to SQL Challenges and Concept series. I am Saharsh Bhatnagar, founder of Seller Smart Academy, and in this video, I'm going to tell you the top 3 ways to find the nth highest salary. Now, the question of finding the nth highest salary is very common when it comes to job interviews or campus placements. And by this question, the interviewers want to evaluate how good we are in ranking and arranging the data and the values associated with the table. So in this video, I'm going to tell you 3 ways in which you can confidently answer the question of finding the nth highest salary. The first solution involves using the dense rank window function. The second is using the combination of the top and distinct keywords. And in the third solution, we'll be using a correlated subquery, wherein I've also covered the concept of what correlated subqueries are and how they are different from nested queries. So without any delay, let's start solving. Alright, so the very first method of finding the nth highest salary is using the dense rank function, and this is the easiest way out of all the 3 ways that we'll be going through in this video to determine the nth highest salary. If you're someone who is new to dense rank or you want to know more about other such window functions such as rank or row number, I recommend that you watch the window functions part 1 and part 2 videos. The links of these videos have been provided in the video description. So let's determine what approach we'll be using to find out the nth highest salary using the dense rank function. First, we'll be writing a simple select query using the dense rank function to assign rankings based on the salary column. For this purpose, we need to arrange the data in the salary column so that we can assign the rankings. And there are only 2 ways to arrange it, either in the ascending order or in the descending order. Since our scenario asks us to determine the nth highest salaries, we need to make sure that the maximum salary appears at the top in the ordering of the rows. So for this very purpose, we'll be using the DESC clause inside the order by in order to arrange the data in descending order. This makes sure that the maximum salary value appears at the top and gets the rank of 1, followed by the second highest salary, which gets the rank of 2, so on and so forth. Once we have arranged or assigned the data, the ranks corresponding to them, all we have to do is write a common table expression or CTE to fetch that row whose dense rank is equal to n, where n is nothing but the nth highest salary in our problem statement. For instance, if we want to find the second highest salary, we need to fetch the row whose dense rank is equal to 2. So in this case, it is quite possible that you can get more than 1 rows if there are more than 1 employees whose salaries are second highest out of all the employees in the entire table. So let's see this thing in action in SQL Server Management Studio. So here I have the employee table, which consists of 4 columns: employee ID, employee name, salary, and the department column. I have arranged the data based on the salary column in the ascending order. So you can see right now that the salary $35,000, which belongs to Mark, is currently the lowest salary in the entire employee table, whereas $8,000 earned by Steve is the maximum salary. Let's quickly write the dense rank query. So first I'm going to write a simple select star from statement here. So I'll write select star from employee, and I'm also going to include the dense rank column. So I'll say dense rank followed by the over clause. Now we'll ignore the partition by clause here since we don't want to partition or group the data. We want to consider the highest salaries across the entire table. So I'm only going to use the order by clause inside the over clause, and I'm going to perform the ordering based on the salary column. Since we want to find the nth highest salary, we are going to arrange the data based on the DESC ordering or the descending order, so that the highest salary gets the rank 1, the second highest salary gets the rank 2, so on and so forth. Let me quickly give this an alias, so I'll call it dr for dense rank, and let's run this query. So you can see the rank 1 has been assigned to Steve, who earns $80,000, which is the highest salary across all the employees. Isabel gets rank 2 as she earned $65,000. This is the second highest salary in the entire table. Jeremy and Chris share the same dense rank of 3 since they both earn $50,000 each, and $50,000 is the third highest salary across all this set of rows. Similarly, Jennifer gets dense rank of 4, Ethan and Alfred share the same dense rank of 5 since they both earned $40,000. And lastly, Mark gets the dense rank of 6, which is the highest value in terms of dense rank, but it is the lowest in terms of the salary. So the highest salary of Steve gets a dense rank of 1, and the lowest salary of Mark gets a dense rank of 6. All we need to do now is to fetch the desired value of n from this dense rank. So I am going to write a CTE, which is a common table expression. So I say with CTE as, and I enclose the select statement in the parenthesis. So I say select star from the CTE because I want all the rows and all the columns from the CTE, but I want to filter the data based on the dense rank value. Now we can simply write dr equal to n. So what is this n over here? The n is nothing but the nth highest salary. So let's say if I want to find the third highest salary, I will be simply using n equal to 3. So I will replace n here by 3, and let's run this query. So you can see the data is correctly displayed. If you remember from the original table, let me just quickly run it. You can see that the third highest salary, since this is the highest, this gets rank 1, this gets rank 2, and these both get rank 3. So you can see $50,000 is the third highest salary, and the result set over here by running this query returns the same. So you can see Jeremy and Chris, both earning $50,000 each and having a dense rank of 3, are the employees who have the third highest salary across all the employees. If you want to find the second highest salaries, all we have to do is simply replace n and make it 2. So I'm going to substitute 3 here by using 2, and let's run this query again. This time we get Isabel. If you remember, there is only one employee who earns the second highest salary of $65,000, which is Isabel. So if you can see, the dense rank approach is pretty compact and fast in terms of execution, and hence this is the easiest method to determine the nth highest salary. The second method is using the top and distinct keywords. So first let's look at the approach that we are going to use to determine the nth highest salary using the top and distinct keywords. Let's say we have the salary column as shown here. So the very first step is to arrange the salary column in the descending order so that the highest salary appears at the top. Once we have performed step 1, as you can see, the maximum salary of 70,000 appears at the top, followed by the second highest, third highest, and fourth highest salaries. Step 2 is to perform the distinct to remove the duplicate salaries from this column. So once we perform step 2, you can see we got rid of the additional 50,000 and 30,000 rows in the salary column, and now all the salaries in this column are unique. Once we have performed the distinct, we will next perform the top n. So if you want to find out the nth highest salary, you should perform the top n. In our case, let's say we want to find out the third highest salary, so we will simply perform the top 3. And all that the top 3 will do is return the very first 3 rows of the entire column. So when we perform the step 3, it returns the top 3 rows, that is 70,000, 60,000 and 50,000, and we call this particular inner query as query A. All we have to do finally is perform the minimum function now using a query B on query A, which gives us the minimum salary, that is actually the nth highest salary in the entire column. So let's see this approach in action by performing the queries A and B in SQL Server Management Studio. So let's come back to the same table, that's the employee table, and this time we'll write the query using the top and the distinct keywords. So the very first step is to write the basic select star from query. So I'll write select star from employee. The next thing, if you remember the strategy, it was to order the data based on the salary column and in the descending order. So I'll write order by salary DESC. The next step was to determine or obtain the distinct salaries. So instead of star, I'll only obtain the salary column, and I'll make this distinct so that I am only fetching the non-duplicate or the unique salaries from the employee table. Lastly, we will be using the top n clause. So I will write top n salary, and then this entire select statement becomes the A query that we have seen in the strategy. So let's assume that we want to find out the third highest salary. So n becomes 3. So let me substitute n here and make it 3. And let's just run the query first to see what is returned by the select query, that is A query. So you can see we obtain the top three distinct salaries ordered in the descending order. So the 80,000 or the first row returned here is the maximum salary. 65,000 is the second highest salary, and 50,000 here is the third highest salary. So now all we have to do is we need to fetch the third highest salary, that is 50,000. So I will simply write a minimum query on top of this A query. So I'll write select min or minimum of salary. Let me give it an alias. Let's say I call it the nth highest salary from the A query or this select query that I have called as A. So now when we run this, we obtain the desired result, that is 50,000, which is the third highest salary. So let me run both these queries together so that you can see if we have obtained the desired result correctly or not. You can see in this table, we have 80,000 as the highest value, followed by 65,000 as the second highest. 50,000 is the third highest. So 50,000 is rightfully returned. If we wanted to find out the second highest salary, all we have to do is replace n, make it 2. So we'll do the same thing over here. Instead of top 3, this time I will replace it by top 2 and run the same query. So this time we get 65,000, which is correctly returned. So this approach is slightly more wordy and lengthier when compared to the first approach of using dense rank, but it's a new technique and it also helps you understand the concepts of using distinct and top keywords to determine the nth highest salary. The third and the final method is using a correlated subquery. Now this method is slightly complex and wordy, and it's also pretty slow when it comes to the execution speed. And when you compare it with the dense rank and top distinct methods, it takes more time to execute. But from the concept building perspective, this is a really good topic to understand as it's pretty helpful in solving various other SQL scenarios. So let's first understand what a correlated subquery is. This kind of subquery basically contains two queries, an outer query and an inner query. Now, this is synonymous to the concept of nested loops in programming. If you are someone from a programming background or if you have done some programming in your career, you must be aware of the concept of nested loops, that is, one loop inside the other. So all that happens is, let's say we have an outer loop evaluated for a variable I and we have an inner loop which is evaluated for the variable j. We take the value of I and we execute the j loop totally or entirely. Once the inside loop, that is the j loop, has executed completely, we go back to the I loop, change the value of I from 1 to 2 and perform the same steps. In the same way in SQL, for every row of the outer query, we perform the evaluations in the inner query. Once these evaluations have been completed in the inner query, we go back to the outer query, get the next row, and repeat the same steps. So the direction of evaluation in this case is from the outer query to the inner query. The row value is determined by the outer query, and then this row is passed on to the inner query to perform subsequent evaluations. The counterpart of correlated subquery is nested query. Nested query works in the opposite behavior of correlated subqueries. That is, the direction of evaluation in nested queries is inner to outer. So let's say I have 100 rows of data and I have a nested query. The inner query will take these 100 rows of data first and will perform some processing or evaluation and filter my data. Let's say after filtering, I have only 60 rows of data left. Now these 60 rows of data that has been obtained using the inner query is passed on to the outer query for further evaluation. So you see the driving force behind this query or the nested query is actually the inner query. The inner query determines what rows will be passed on to the outer query. So the direction of evaluation is inner to outer when it comes to nested queries. Moving along the lines of the correlated subquery, let's now find out the approach that we'll be using to determine the nth highest salary. So let's say I have a salary column which consists of random figures, and as you can observe, we also have duplicate entries for 50,000 and 30,000. So the very first step is to get rid of the duplicates by using the distinct keyword and obtain the unique salary numbers, which are ordered in the descending order. So I have the maximum or the highest salary of 70,000 and the lowest salary or the minimum salary of 30,000. Now, if we want to determine the third highest salary, all we have to do is simply point to the third location in the salary column. This is because the third highest salary means that there are 3 minus 1 or 2 salaries that are always going to be greater than the third highest salary. That is 70,000 and 60,000 are those two salaries which are always going to be greater than 50,000, that is the third highest salary. On the same lines, if we talk about the fourth highest salary, we can confidently say that there are going to be 4 minus 1, that is 3 salaries that are always going to be greater than the fourth highest salary itself. So to generalize, I can say that if for a salary, the row corresponds to the nth highest salary, there are definitely going to be n minus 1 distinct salaries which are greater than the nth highest salary. So all I need to do is simply check if for any given row, the count returned is equal to n minus 1 or not. And for this very reason, I'm going to use a correlated subquery. So the first task is to create an outer query which simply reads every row and simply extracts the salary of every row. Once I have obtained the salary from each row, I'm going to pass this salary to the inner query. The job of the inner query is to find out the count of those salaries which are greater than the salary passed by the outer query. If the count returned by the inner query is equal to n minus 1, then we have found the nth highest salary. If not, we move on to the next row and perform the same operation till we reach the count of n minus 1. So let's draft the final solution to find out the nth highest salary for the correlated subquery method. The first part of the query is the outer query, which is nothing but all the columns returned to the inner query. So we are simply passing the salary details to the inner query. So for the outer query, I'm going to write the select star from statement. I'll write select star from employee and I'll give it an alias of OQ, where OQ stands for outer query. But for drafting the inner query, let's understand the prerequisites. So the inner query should return the count of all the distinct salaries that are greater than the salary passed by the outer query. So there are two conditions. First, that the distinct should be performed in the salary column, and then we should count these distinct salaries. And secondly, the salary of the inner query should be greater than the salary value coming from the outer query. So first we write the very base query, that is a simple select star from statement, and we will give it an alias of IQ, where IQ stands for the inner query. Now instead of the select star, we are going to use the count of the salary, and first we'll implement the condition of distinct. So I'll write count of distinct salary, and next we'll implement the condition that the inner salary should be greater than the salary coming from the outer query. So I'll write where IQ or inner query dot salary is greater than OQ or outer query dot salary. So this entire query constitutes the inner query and this query constitutes the outer query, but both of these are still not correlated. So we need a condition on the basis of which we can correlate these two queries, and that condition is that if the salary is the nth highest salary, then the count returned by the inner query should equal to n minus 1. So I'll say where n minus 1 should be returned by the inner query. So all I need to do is simply replace the parentheses which are empty and substitute the inner query in them. So this entire query forms the solution query to determine the nth highest salary. Now let's say, for example, we want to find out the third highest salary. So in that case, the value of n is 3. So let me first quickly copy this query so that we can make changes over here. And let me substitute n and make it 3 since we want to find out the third highest salary. So instead of n, I replace 3, and 3 minus 1 evaluates to 2. So I'll run this query, and this returns the third highest salaries in the employee table, which belong to Jeremy and Chris, that is $50,000 each. Now let's say if I want to find out the fourth highest salary, I simply need to substitute the value of 4 in place of n. So instead of n, I will substitute 4, and 4 minus 1 evaluates to 3. So I'll run this query, and I obtain the fourth highest salary, which belongs to Jennifer, that is $45,000. So simply remember the golden rule that if we are determining the nth highest salary, we need to substitute n minus 1 over here in the where clause condition. So these were the top 3 ways to find the nth highest salary in SQL. If there is any other topic or scenario in SQL that you wish to know more about, please mention the same in the comment section and we'll be glad to make a video on the same. Thank you so much for watching.